Hello, folks. All right, so in this video, we're going to look at compound and double angle formulae, right? So these are your compound angle formulae, right? So if you have sine A plus B, that is equal to sine A cos B plus cos A sine B. If you have sine A minus B, that is equal to sine A cos B minus cos A sine B. Then if you have cos A plus B, this is cos A cos B minus, and notice minus sine A sine B. However, if it's cos A minus B, then we have cos A cos B plus sine A sine B, right? Then your double angles. We've already looked at sine 2A, which is 2 sine A cos A. Then cos 2A, I think we also looked at this one. It gives us cos squared A minus sine squared A, 1 minus 2 sine squared A, 2 cos squared A minus 1. Right? If you notice that I'm reading these things out because I actually want you to know and understand them very, very well. Right? Because as much as the formula sheet is given to you, if you don't understand these formulas, then the formula sheet will just be a tool that is ineffective for you, right? So you have to know and understand them in order for you to be able to apply them. So we have our product sum or product to sum, which is 2 sine A sine B, this being equals to cos A minus B minus cos A plus B. Then 2 cos A cos B, cos A minus B plus cos A plus B. Okay? Now, you have to recognize the patterns also in reverse. And what do we mean by that? We mean that if you see sine x cos y minus cos x sine y, you have to be able to see that this is sine x minus y. If we see cos A cos B plus sine A sine B, this is cos A minus B, right? If you see cos A cos B minus sine A sine B, this is cos A plus B. If you see sine X cos Y plus cos X sine Y, this is sine X plus Y. So you always have to look at these patterns before you start simplifying. Always make sure that you carefully identify these patterns, right? Okay, so here's an example. Simplify cos 56 cos 26 plus cos 146 sine negative 26. You can pause the video and try it out. Right. So, first thing first, we're going to reduce 146, right, and write it using the reference angle 34. So cos 146 is in the second quadrant, so it's negative. Cos is negative there. So this is negative cos 34. And then notice that 34 plus 56 is equals to 90. Right? 34 plus 56 is equals to 90. So why is that important? That is important because it means now, instead of writing this as cos 34, we can write it as cos 90 minus 56. Why are we interested in 56? Because we already have cos 56 there. Right? We already have cos 56 there. So we want to write this with angle 56 as well. Because you have 56, you have 26, and you have another 26 there. So it makes sense for this to also be 56, so that you can end up with 56, 26, 56, 26. Right? So remember, in our previous video, we said that when you have 90 minus an angle, then you swap your trig ratios from cos to sine. So this becomes sine 56. Right? Then sine of a negative angle is equal to negative sine of that angle. We looked at this as well in our previous video. Now with all of this, then we can substitute our stuff. Now notice that when we substitute, we end up with cos 56, cos 26 plus sine 56, sine 26. Lo and behold, this is cos A minus B, right? So this is cos 56 minus 26, which is cos 30. And using our massive triangles, we know that cos 30 is equal to root 3 over 2. Right? So very important for you to be able to recognize the pattern. Right? Recognize the pattern. Okay. Now let's look. Here's another one. Show the value is independent of A. So this is what is given to us. Now, before you even start looking at what is going on, just notice the pattern. Sine angle, cos angle, minus cos angle, sine angle. Look, notice the pattern, right? The structure represents sine x cos y minus cos x sine y. And we know what this means. This matches sine x minus y. Being able to recognize that makes your calculations much more easier, because you can just substitute a plus 40 where there's x and a plus 30 where there's y, and that gives you sine 10. And notice that sine 10 is just a number, so it doesn't have it does not depend on a at all. This means that no matter what the value of a takes, the expression will always equals to sine 10, regardless of what a is. Right? So we sorted. Right. Now, here's another one. Evaluate without a calculator. You can pause the video and try it out. 2 sine 75 sine 15. Right. So in my mind already, I'm thinking that 75 would be 45 plus 30 my special angles. 15 would be 45 minus 30. Right. So you can use your product to sum formula here. 2 sine A sine B is equals to cos A minus B minus cos A plus B, right? And if you substitute those things, then this gives you 1 over 2, right? Or, I mean, really, if you forgot about your product to sum rule, you can actually do it as I explained. So 75, you write it as 45 plus 30. 15, you write it as 45 minus 30. Then you expand, right? Expand and simplify, and you should also get 1 over 2. Okay? Now, prove cos 15 is equals to square root 3 plus 2 over 2. You can pause the video and try it. So now, if we use the identity cos squared A is equals to 1 plus cos 2A over 2, which is a rearrangement of double angle formulae. Remember, the double angle formulae is 2 cos squared A minus 1. right, is equals to cos 2a. So we're just rearranging that double angle formula here to get this. Now from that, if we let a be equals to 15, then 2a is 30. Right, so this then becomes 1 plus cos 30 over 2. And we know cos 30 is root 3 over 2. Then from there, chi. Right, now we have to take the square root so that we can remove the square there. Yeah. Now, since 15 is in quadrant number 1, then it means cos 15 is positive. So when we take the square root, we'll take the positive there. And yeah, it gives us what we expected. Okay, folks, again, please pause the video and try this exercise. All right, folks, if you've done the right thing, then these are your solutions. Mm-hmm. Mm-hmm. Okay, so in our next video, we're going to look at proving trigonometric identities. See you in the next one, folks. Danke.